Morning, I'm Auni Aqilah. This is Eka Latiffah. This is Nur Akma, I'm sorry. This is Eka Latiffah, Siti Nabihan, Nur Hazirah, and Nur Kamilah, and we are from the group 2. And today we'll be presenting about a glucose oxidase.
Okay, so here are the characteristics of glucose oxidase that have been explained by the previous group. It's just that our isoelectric point of glucose oxidase found is 5.02.
Next, I will explain about the catalytic reaction. First, we know that this enzyme is to oxidize beta-D-glucose in the presence of oxygen to form D-glucono-delta-lactone and hydrogen peroxide. So, as you can see, the first reductive half reaction, the glucose oxidase will oxidize beta-D-glucose to gluconolactone, which will then spontaneously hydrolyze to form gluconic acid. At the same time, the FAD, which in this case acts as electron acceptor, will be reduced to FADH2. So this reduced sugar will then reoxidize by oxygen to form hydrogen peroxide in oxidative half reaction.
Now I will explain the symmetries and differences glucose oxidase in different living organisms. In this example, we are going to compare between Aspergillus and Penicillium. These both fungi have the similarities in using the same substrate for glucose oxidase, that is beta-D-glucose. And the differences found in it has the difference parameter. For example, in thermal inactivation parameter and catalytic parameter. These both fungi have different value of Km and Vmax, and also difference in quantitative immunological reactivities.
Okay, as in the important applications and industrial value of GOX, it is used to determine free glucose in sera, blood plasma, urine for medical diagnostics, and then it monitor glucose levels in fermentations and bioreactors, control glucose in vegetal raw, as an additive in the food industrial, like white, and then prevention of alteration in the taste of wine, and then glucose oxidase plus lactoperoxide is also being used in chewing gum for promoting oral health, and also development of bioelectrochemical cell.
Okay, task 3 asks for the protocol how to measure the enzymatic activity of glucose oxidase in different substrates for glucose, fructose, and galactose. Okay, based on Magazine International Island 2014, by using the method of continuous spectrophotometer rate determination, first we have to pipette 2 ml of peroxidase solutions and 0.5 ml of a glucose solution as a substrate into the cuvette, and then we mix the reaction by chemical inversion after we cover the cuvette with cap, and by using the plastic spatula, and then after 5 minutes we read the absorbance value using the spectrophotometer at 510 nanometer of wavelength, and the value is assumed as the first absorbent A1, and then we add 0.5 ml of glucose oxidase solution into the cuvette. For blend solution, we substitute the glucose oxidase by using the 0.5 ml of distilled water. And after exactly 20 minutes, we mix the reaction again, and we read the absorbance value as the A2. And we repeat the experiment by using the different substrate of fructose and galactose, and we can calculate the glucose oxidase activity based on differences value of absorbance A2 minus A1 in unit form in unit 2 per L. 2 over L. And why we use this method is because it's more accurate and save more time.
Okay. Now I will explain how to extract glucose oxidase from Aspergillus niger. Okay, first we have to isolate the Aspergillus niger. Then we have to put in a test tube. Then we add a liquid nitrogen to the test tube. The nitrogen will be evaporated and it will be produced biomass in a powder form. Okay, after that, add 5 ml of sodium citrate buffer. This buffer have a pH 5.5 because glucose oxidase is active at this pH. Okay, then test tube will be centrifuged at 3000 G for 20 minutes at 40 degrees Celsius. After we centrifuge, then it will form 2 layers, upper and lower. The upper is a supernatant and the supernatant will be extracted for further purification. Okay, the advantage we use this method because the method is simple and easy to perform, and then the material can be obtained locally and cheap.
Alright, as for further purification of GRX, the journal article that I found is written by Bennett et al. In the year 1964. This protocol is a bit ancient, it's about 50 years ago. And the aspergillus niger extract is added with sodium acetate and then dialyzed to filter all the to separate proteins based on their electrolytes present in the extract. And then the brown precipitate form by centrifugation will be removed, and the supernatant that contain the GRX activity will be taken and will be eluted in the column buffet of amber light CG50. And then the elution bounded will form a yellow solution. And next, the process of adding ammonium sulfate to form a protein precipitate, and then the protein precipitate will be redissolved with the sodium phosphate buffer. And then the process will be dialyzed again and then added into a column, a different column of DEAE, a cellulose column that is buffered with sodium phosphate buffer, and then it again will obtain a yellow solution, and then the process will be repeated again by adding ammonium sulfate, and then the precipitate form and redissolve in water and dialyzed against water will be taken for determination that will be further explained by my colleague.
Next, we proceed. After we have purified the protein, so how we want to know the protein is our targeted protein? So first, we can run SDS page. This page we use because it can separate the protein on the basis of molecular weight. Okay, if our protein is purified, we will get single band, and in our case is glucose oxidase with a molar mass of 65 kilodalton. So we will get single band in between 55 to 70 kilodalton. But there is a problem using SDS page. What if there is another protein that has the same molecular weight with glucose oxidase? So we can do Western blotting. In Western blotting is used to detect our targeted protein. First, we will transfer from a gel to a membrane. Next, we will blot the unoccupied binding sites, and we will use two types of antibodies. The primary antibodies will bind to our targeted protein, which is rabbit antibody, and the secondary antibody will bind to the primary antibody, which is good anti-rabbit antibody. Next, we will detect. Next, we can also use enzymatic activity. We know that this enzyme is used to oxidize beta-D-glucose. So if we put or apply substrate beta-D-glucose and we get in the end of the reaction D-glucono delta lactone and hydrogen peroxide, it means that it is our targeted protein. Next, how to know there are no significant contaminants? In our example is for DNA as contaminants. So we can run agarose gel electrophoresis. There are two possibilities. If there is band formed, it means there is DNA, and it means there is a contaminant in our purified protein. If no band form, it means our protein is pure.
Okay, so next is the how to determine the 3D structure of glucose oxidase. First, what you have to do is you must have Yasara software. We use Yasara, and this is the 3D structure of glucose oxidase. Okay, here is the same too, but in the style of ribbon and ligands, which you can see the alpha helix and beta sheets are the proteins, and those that are ball and stick style are the ligands. Okay, so we use uniprot.org. First, okay, if you see the one that is circled, glucose oxidase, and the enzyme is extracted from Aspergillus niger. Okay, so what you have to do is copy the sequence of amino acids and paste it on in Microsoft Word. Okay, and we repeated the same thing for the other two organisms, which are Penicillium magasekinse and Thalaromyces flavus, and paste it on Word. So what you have to do next is okay, go to cluster W2. This is how the web looks like, and copy the amino sequence for those three organisms, and paste it in cluster W2. So what we should get here is the comparison between comparison of those sequence of amino acids between those three organisms. So the one that is labeled star represents the similarities. So those are likely to be the binding site and can also be the active sites of these glucose oxidase. Okay, so there are three important amino acids that are responsible for catalytic activity, which is histamine 516, glutamate 412, and histamine 559. Histidine, sorry. Okay, so this is the 3D structure for histidine 516. Okay, so why do I use bioinformatics tools? Because it is easier for me to compare the amino acid sequence from those three organisms that I have mentioned, and the details of a particular protein are all provided in bioinformatics tools, and also it saves cost and time because there is no experiment needs to be undergone. Okay.
Okay, so this is the last part of our presentation. For the task 8, it asks about how can we analyze the protein structure in change of temperature. So as the temperature increase, the kinetic energy is also increased, and this is caused the denaturation of 3D structure, which is change in active site of the enzyme. So this is the two methods to analyze the protein structure, which is X-ray crystallography and MR spectroscopy. Okay, this is the general figure of X-ray crystallography. For the first, the protein is crystallized and this is the crystallography is the most powerful method to obtain a macromolecular structure. Instead of NMR spectroscopy, it just can analyze the atomic structure of micromolecular structure. So we more prefer for X-ray crystallography instead of NMR because the size of the enzyme that we use is glucose oxidase, which is the molecular weight is 60 kilodalton, which is not maybe it's difficult for NMR chromatography to analyze the detail of the atomic. So I think for the overall presentation, this is the last part, and that's all. Thank you.